first case on Mid-Ordinate rule, you'll be told, use Mid-Ordinate rule with 6 intervals to evaluate the integral, isn't it? Now, if you want to use Mid-Ordinate rule, the first thing we say is even before you identify the rule you are using, you must know how many intervals do I have, isn't it? Are we together? How many strips, isn't it? So here, in Mid-Ordinate rule, you know how many parts do we have? In Mid-Ordinate rule, we know the number of strips is the same as the number of intervals, which are the same as the number of ordinates, because intervals are for each and every strip, isn't it? So, look at this. In integration, if you want the area under a curve in integration, so you are integrating the function of x dx. So that is how to get the area under curve. You integrate f of x dx, meaning f of x, meaning if you are given this as your curve here, y is equals to maybe x squared plus 2, and you want the area under this curve maybe from 0.2 to 0.8. You want the area under this region, and this is the curve you'll be given. For you to get that area, you'll be integrating from 0.2 to 0.8. Let's say this curve here, y, is x over square root of 1 plus x cubed. That's an example, okay? So when you are getting the area under this part from 0.2 to 0.8, you will be integrating from 0.2 to 0.8 of the function f of x of y, isn't it? Of x over square root of 1 plus x cubed with respect to x. And you can see x times dx, that is exactly what you have there. So you see, the area under that curve, they will not be bringing it open like this. They will be bringing it when it is already been put in form of an integral. And in real sense, this is what you are looking for. Are we together? Are you seeing what is happening? So it means what you are integrating, the whole of this what is here is the function of x, isn't it? So it means here you are integrating from 0.2 to 0.8 of x over square root of 1 plus x cubed with respect to x, f of x dx, meaning this is f of x. And what is f of x? So it is the y, which is the function of x, isn't it? Meaning f of x is y. Are you seeing that? Are we together? So it means the value which is inside here is always the y from here. Because this is f of x. This part, the whole of this, because it's f of x dx, isn't it? So it means the whole of this is the f of x. And that f of x is the y. Is the y. So anytime you are evaluating the area, whatever is inside the integral is the function. Isn't it? So we demonstrated that. So having demonstrated that, it means when you are told to determine the area under curve, the first thing you will know the function there you are integrating, meaning y to be equals to whatever is inside there. Dx means you are integrating with respect to x. So what is left if you remove dx? It is x over square root of 1 plus x cubed. So you found the function you are integrating. Are you seeing that? Are we together? Are you seeing how to get it? You simply remove with respect to dx. If you block dx, whatever is remaining there is the y. We've demonstrated that. Are we together? So having seen what we want to integrate the y, then this y is what we are going to help us to get the ordinates from y0. Meaning if this is y0, where there is x, you put it because ordinates are in the form. If it is x0, it is y0, isn't it? If it is x1, it is y1, isn't it? If it is x2, you have y, the coordinate system, isn't it? Meaning here, if you put y1 where there is x, you put x1. So you see, any moment you will have the x values, it will help you to get all the corresponding y coordinates. And because those y coordinates are what we are interested in to get the area using Mid-Ordinate rule. Are you seeing that? Are we together? Very good. So that part has been explained, isn't it? So the next thing, for you to get the area with Mid-Ordinate rule, you've been told to use how many intervals? 6 intervals. And you know, 6 intervals, each part or strip has its own interval. So 6 intervals means how many parts? How many strips? Yes. So you come, your 6 intervals imply 6 parts, 6 strips, isn't it? And now from here is now you evaluate in Mid-Ordinate rule. How many ordinates do we have? What is the relationship between strips and ordinates? Because we want to get the ordinates. Are you seeing that? Are we together? In mid-ordinate rule, each and every part has one ordinate in the middle in mid-ordinate rule, isn't it? So even if each and every part has one ordinate in the middle, meaning the number of parts or strings are the same as the number of ordinates. So I know I'm going to use 6 ordinates. Then you come and you list your 6 ordinates, isn't it? Your 6 ordinates are Y0, Y1, Y2, Y3, Y4, Y5, and Y5 is the last one because you started from Y. So you started from Y0. So it means Y5 will be the 6th ordinate, isn't it? Yes. So you know the kind of ordinates you are going to get. Meaning if you put Y0 here, then where there is X, you put X0. When you put Y0 here, anywhere you see X, you put X. Isn't it? Yes. When you want Y1, anywhere you see X, you put X. Are you seeing how you are going to get there? When you want Y2, because those are coordinates. Those are coordinates. So the next thing we need to get is what? Is that H is what comes first before you get this. Because it is that interval, equal interval. Meaning if you have the first X value, X0 will give you the next X value, isn't it? Are we together? Yes. So there are 2 things you need to get at once. You need to get H, and you also need to get the starting point X0. So you cannot get X0 the starting point before you get H. Are you seeing that? Because H is the interval, the size of the interval, isn't it? So the size of the interval, you have how many intervals here? 6? 6 intervals. 6 intervals, meaning H is going to be the whole range divided into 6 equal parts, isn't it? So remember you are starting from 0.2 and you are ending at 0.8, isn't it? Meaning what is the whole of this length? It is 0.8 minus 0.2. Yes. You get the whole of this length to be 0.6. Now this 0.6, you want to divide it into how many equal intervals? 6 equal intervals. You want to divide 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like that, 6 equals intervals, isn't it? So each interval, there must be equal interval H. So what is H? The whole length is 0.6 and it is divided into 6 equal. Are you seeing how to get H? Are we together? Yes. Tuko pamoja? So we've seen H is what? 0.8 minus 0.2 divided into 6 equal parts or 6 equal intervals. Are we together? Yes. So the whole weight is 0.8 minus 0.2, then divided into 6 equal intervals. Then you get what? 0.1, meaning each and every interval is going to be 0.1. Now the next thing you need to get is X0. Once you have that X0, it is just X0 plus H to gives you X1. X1 plus H to gives you X2. X2 plus H to gives you X3. Because those H are the equal intervals. Are you seeing that? Yes. Isn't it? Yes. So what you need to get is X0 only. The rest H will be, you will be adding H and getting the rest, isn't it? Yes. So how do you get X0? You simply take that first part only. It is starting from 0.2 and the whole of this interval H you found is 0. Are you seeing the reason why H has to come first? Yes. Are we together? So when you go here, you now check in mid-ordinate rule. When it is not mid-ordinate rule, meaning X0 start here. X0 is there on the spot when it is not mid-ordinate rule, isn't it? So when it is Simpson's or trapezoidal rule, then X0 you have here there on the spot 0.2. So you simply add H to it and you are done. So it means in Simpson's and trapezoidal rule, there's no need, you don't look for the X0, it is already there, the start, isn't it? Yes. But in mid-ordinate rule, it is not there, you are looking for it. Are you seeing what is happening? In Simpson's and trapezoidal, you are starting from the first ordinate, meaning X0 will be 0.2 in trapezoidal rule, X0 will be 0.2 in Simpson's rule, isn't it? But in mid-ordinate rule, it is not starting here, it is starting in the middle. Are you seeing where your X0 is in mid-ordinate rule? Yes. Very different with the other two, isn't it? Is that understood? So what is the value of this X0? You know here is 0.2, the whole of this interval is 0.1. So you see 0.2 plus 0.1 you get here is 0.2. So it means for you to get X0 the midpoint, so it is the midpoint here 0.2 plus 0.3 divided by 2. Are you seeing? Are you seeing how I'm following procedure to get these things? Yes. So it is your 0.2 plus the h to give you the next interval. So this is the first interval helping you to get x naught, because x naught is in this first interval, isn't it? So it is there, x naught is the average 0.2 plus 0.3 divided by, you get it is 0. So it means this value in the middle here is 0.25. Are we together? So you found x naught is 0.25. So it means the next here, from here, your h here is 0.1. So 0.3 plus 0.1, you see, get 0.4. The middle point here will be what? 0.3? Because you can see this is the midpoint, meaning from here to here is a half edge, and from here to here is a half edge. So coming from x naught to x1 here, a half edge plus half edge is also what? Edge. Have you seen that? That's why I'm saying once you found x naught, it is just x naught plus h to give you x1. x1 plus h to give you x2. Just as the same when you are in trapezoidal rule, x naught starts here, isn't it? So it is still the same x naught plus h to give you x1, still the same, isn't it? So what you need to know is how to get the x naught only in a given rule, isn't it? In trapezoidal and Simpson's rule, x naught start at exactly that point. It is only the Mid-Ordinate rule where it starts at the middle, so you have to look for it, isn't it? Are we together? Good. Now once you found x naught and h, then you are done. You simply form a table, because from the table, we want the y ordinates, because these y ordinates are the lengths, are the ones used in the formula, isn't it? You know Mid-Ordinate rule is going to be what? The area in Mid-Ordinate rule is going to be h into the sum of the ordinates, isn't it? And what are your ordinates? Y naught plus y2 plus y4 plus, that is how you are going to get the area in Mid-Ordinate rule, isn't it? So it means you come and form a table to get these y's. There are how many of them? 6 of them. They are 6 of them. So form a table with the 6 parts. 1, 2, 3, 4, 5, 6. So let us start. We will have our x naught, then x naught will give us x1, isn't it? Then x1 will give us x2, x2 will give us x3, x3 will give us x4, then x4 will give us x5. So x naught, we have it there, 0.25. So you know it is x naught plus h to give you x1, isn't it? So x naught plus h, what is your h? You can write your h on top here. Your h is 0.1, isn't it? So x naught plus h, you get 0.3, you get x1, isn't it? You move again, x1 plus h to give you x2, because that is the interval, the equal interval, isn't it? Are we together? Okay? Yeah. So if you don't want to confuse, you can even write it beside here, h is 0.1. x1 plus h to give you x2 is 4, 5. x2 plus h to give you x3 is 0.55, isn't it? x3 plus h to give you x4, 0.65. x4 plus h to give you x5, 0.75. So you can see the last one cannot pass 0.8 because those ordinates are in the middle, isn't it? If you add plus h again, you see it is past 0.8, meaning that is outside, is not required, isn't it? Are you seeing? Good. So from this, we now get the coordinates, isn't it? Meaning x naught will give you y, x naught will give you y naught, isn't it? x1 will give you y, y1. x2 will give you y, y2. x3 will give you y, because those y's are what we need, isn't it? Then x4 will give you y, y4. x5 will give you y, y5. Then now you go to the formula which is relating x and y, isn't it? Are we together?
Yes.
That is now what you feed in the calculator. When x naught is 0.25, you get y naught. Meaning where there is x, you put 0.2. Isn't it? To get y, meaning if here is y naught, then where there is x, you put x naught. So x naught value you have. Where there is x naught, you put 0.25. Then the whole answer will be what? Are you seeing that? The whole answer will be y0. Now, if you are using that calculator which is not outside or which is out of order, this is what you do. Look, the way you are going to get these values very easily. This is what you do. You just say numerator is x. You say that x, you start with pressing the value of 0.25 is equals to 0.25, isn't it? Now it is the answer. So you say the numerator there is answer, where there is x you put answer. It is answer in bracket divided by, then you go to the numerator. That bracket means the whole of it is the numerator, isn't it? Then square root, then you put smaller bracket, because if you don't put smaller bracket, it means you are looking for the square root of this term only in that calculator. The fake one. Are we together? 1 plus answer cube. You close the top bracket. You close the bracket inside, then you go outside, you close the bracket which is outside. Are you seeing that? Are we together? My friend, if you cannot abide with that rule, can you go stepwise? You know very well that y is equals to x over square root of 1 plus x cubed. When you want to x naught, where there is x, if you put x naught there, you put y naught. So y naught will be x naught of this, then get this value the way it is, okay? So start, x naught is 0.25 over square root of 1 plus 0.25 cube. You get the answer. Where there is x naught, you substitute the value of x naught. And you know every time you substitute something, you bracket. You don't have to calculate when you're doing numerical methods. So, this is exactly what I've talked about now. Look at this. This is extremely wrong. It is not just wrong, but it is very wrong. And it is very, very uncouth work. She's coming and saying 0.25 over. This is absolute nonsense. Then after that, she's saying square root of 1, then plus in bracket 0.25 cube. Why are you getting the square root of 1, not the square root was for the whole of this thing? See, that is what I've explained by putting the bracket which opens here and putting the bracket which ends there. See, that is what I've explained just now. And you know, she's very happy that she has found the value. Then after the exam, she's now come and start complaining that the paper was not marked well. And she's the one who does absolute nonsense. So you have your y1 is 0.35 over square root of 1 plus x1 cubed. You are 0.35 cubed. What do you get to be y1? 0.3427. Yes. You go to the next one. The next one is y2. Y2 means if you put y2 here, there you put x2. Meaning you are going to substitute x2 is 0.45. It is 0.45 over square root of 1 plus x2 cubed. x2 is your 0.45 cubed. What do you get? So you get y2 is 0.4? 4308. You now done with y2, you move to y3. y3 means if here is y3, there is x3. So y3 will be x3, which is 0.55 over square root of 1 plus x3 cube. 0.55 cube. What do you get to be y3? 0.5093. You are done with y3. You move to y4. y4 is, we're done with that. When you put 4 there, you put 4 for x. Meaning y4 will be x4, which is 0.65 over square root of 1 plus x4 cube. x4 is that you are 0.65 cube. What do you get to be y4? 0.5757. You move to y5. y5, it means you now put 5. Where there is y is 5, x is 5. So it will be x5, which is 0.75 over square root of 1 plus x5 cube. 1 plus 0.75 cube. What do you get to be y5?
0.6.
0.6?
290. 0.6. 0.6290.
0.629? 0. So you work with 4 decimal places, but some cases we are done with y5. Our equation function still remains the equal, isn't it? Now, in many cases you will be told, maybe give your answer into 4 decimal places, leave your answer into 8 decimal places, meaning you will be working with a number of decimal places you will not be told, isn't it? But if you've not been told the number of decimal places to work with, you will always know it is 4 significant figures. In this case, 4 significant figures here you can see is coming up to be 4 decimal places. Are you seeing that?
Yes.
Are we together?
Yes.
If you've not told, it is standard to use 4 significant figures. In our case, because they are 0 points, then it means 4 decimal places. Is that okay? In many cases. But some cases they will tell you. So when you are not told, you use something which is making sense. You don't come here and start rounding off these things to 2 decimal places. You will be getting an area which is over approximated, isn't it? Are we together? Yes. Now after this, we now get our area. Our area is h into y0 plus y1 plus y2 plus y3 plus y4. So the area, you write the area there on top because you have the formula and the values. It is the work of the calculator to get to the area. Not that you come here and you say what is h. H is 0.1. In bracket, what is y0? 0.2481. Then plus what is y1? 0.3427 plus. That is a waste of time. Once you have the formula and the values, it is the calculator to give you the final thing. Not that you come and rewrite what you are substituting here. That is the work of the calculator. Are you seeing that? Yes. Your work is to write the formula and the values you are substituting in the formula. Then it is the calculator which does that substitution. So can you go to the calculator where there is h, put the value of h 0.1 in bracket, then add all your y's. What do you get to be the area with the mid-ordinate rule? .2736. 0.2736, what do you have there? You will never understand this guy. If you try this next time, then you will not make sense at all in this class, sitting down without a calculator. What do you have? 0.27336, if you round off, isn't it? Is that what you have over there? Good. So that is how to get the area with the mid-ordinate rule.